Hello students, today we're going to be covering biconditionals and counterexamples. So yesterday we kind of warmed up to the idea with conditional statements. So we're going to learn about two kind of more specific aspects of conditional statements today. All right, there we go. So to start off, let's define our new terms. We have a biconditional, which is a statement where both the conditional and its converse are true. It's written in a special form. So a biconditional is not quite a conditional where you write it in if-then form. It's actually written in if and only if form. So if you see if and only if, that's telling you that you're dealing with a biconditional. So for example, and I'm going to keep referencing the parallel lines and transversals bit. I'm going to write a biconditional based on this because as it happens, the conditional and the converse are both true. So if we have if two parallel lines are cut by a transversal, then the corresponding angles are congruent. But if I flip it around to the converse, such as if the corresponding angles are congruent, then the lines cut by the transversal are parallel. Both of these statements are actually true. We know the top one is true because we did that. But it also goes that the corresponding angles are only congruent if the lines are parallel. So you can actually flip that statement around and it'll still be true. And that gives us a very interesting relationship here where that if and only if comes in. The corresponding angles are congruent if and in the only case that the lines are parallel. So we can rewrite that as a biconditional, because this is a lot. So we can rewrite that and make it a little bit shorter with the biconditional. So we can say corresponding angles are congruent if and only if the lines are parallel. That's a bit shorter, right? So that if and only if is telling you that both of these statements are correct. And you can go both ways. So we wrote out the statement and its converse and turned it into a biconditional, but you can also take a biconditional and break it apart into two statements. So to break this apart, you would make one statement where if corresponding angles are congruent, then the lines are parallel. Or if the lines are parallel, then the corresponding angles are congruent. And to be honest, I don't think it matters much which one's the original and which one is the converse, because they're both true, but I could be wrong about that, honestly. All right. So now let's look at an example, or rather not an example, but let's talk about a counterexample. So we touched on briefly yesterday when we talked about the examples where if it is not Saturday, then there is school. But what about Sunday? Sunday's a day that's not Saturday, but there isn't school. And so we identified that whenever a statement is false, we need some sort of counterexample. And the counterexample is something that was true for the hypothesis, but false for the conclusion. It's true that there's no school on a Sunday, but it's false that Sunday is Saturday. So let's put that in some words. Counterexample is used to prove a counterexample false. It must show the hypothesis is true, but the conclusion is false. So hypothesis true, conclusion false. There's a lot of different ways that you can have counterexamples. I'll do two examples here. The first one I'll make a little bit simple, and the other one I'll make math related. So if it is a dog, then it has brown fur. So right away, hopefully a lot of you are going, no, that's not quite right. My dog is white, or my dog is black, or my dog has spots, or whatnot. Not every dog is brown. And that's exactly what you should be thinking. Those counterexamples you're coming up with right away are all wonderful. So there's a lot of different possible counterexamples to a statement like this. As long as your counterexample is a dog, has to be a dog, but it doesn't have brown fur. So like a Dalmatian. I don't know if I spelled that right. Oh goodness, I don't think I did. A Dalmatian, like 101 Dalmatians. I just realized I don't know how to spell that. Anyway, it's black and white. Or you could even say my dog has black fur, or my dog has gray fur, or my dog has all different colors of fur. Any of those would work. However, if you say, well, my cat has brown fur, that's false for the hypothesis, so it doesn't work as a counterexample. If you say, well, I'm sorry, I just blanked. I mean, if you try to say, well, my dog has brown fur, that doesn't work as a counterexample because it's true for both. So it has to be a dog that doesn't have brown fur. Let's take a look at a math example. If an angle is acute, then it measures 45 degrees. So it is true that an acute angle can have a measure of 45. 45 is less than 90 degrees. So technically it's true in a way. But the assumption that all acute angles would measure 45 is what's incorrect. So just because it's acute doesn't mean it has to be 45 degrees. So there's a ton of counterexamples to this one, and you only need to pick out one. So what if it was 46 degrees? That's still less than 90. It could be 15 degrees. It could be 89 degrees. Any of those count as counterexamples because it's true that the angle is acute, but it's false that it measures 45 degrees. All right, so I think that's all I have for the lesson today, guys. Pretty short and simple, I hope. And you have 5 questions on Schoology to answer. I tried to keep them pretty basic for today. So just remember, a biconditional is a statement when a conditional and its converse are true. You can write it as a biconditional. You always have to have a counterexample to prove, oops, I wrote something off in my notes. It said used to prove a counterexample false. Look at me, I'm making all kinds of mistakes. Used to prove a conditional. Used to prove a statement false. Used to prove any of these things false. Okay. And yep, we're good to go. All right, I'll see you guys next time.